The find target test is the first of what I would actually call a hybridized test. What I mean by this is that the test does not only test our particles for a certain criteria, but it also alters your particle in the first place so that they actually meet the criteria you have defined. In this way, these hybridized tests combine the function of a particle altering operator and a test all rolled into one. The find target test can be used to detect when a particle reaches either its own test gizmo icon or a defined set of objects. What it offers over using, say, a force gravity and a collision operator is more control over how the particle reaches their target and also where the particle reaches their target. Beyond this, you also have the option of defining the current target via scripting. So, all in all, the find target test is a very useful operator. When you create the test, particle flow will automatically make an accompanying icon that initially will be the target for your particles to reach. You can use this icon's gizmo if it suits your needs, but if not, you should still leave it be, as deleting it will also delete the test that it's paired with. In our example file, which you can see running here, I'll actually run it for you. There we go. I've used 6 geospheres as targets for the find target test. As you can see, the particles are being emitted and then are flying towards each of the assigned target meshes in a set manner. When they reach the mesh assigned to them, the test becomes true and the particle is passed on to the next event where it's actually spawned to make a brief puff of red particles. This hybrid test actually has 3 main functions. Firstly, it will define a target for each particle based on the parameters in the target group of the rollout. Secondly, it will guide our particle's speed and direction to make the particle come into contact with its defined target. This impulse can either be based on speed or on time as its defining factor. Thirdly, the test will, yes, test to see if the particle has reached its target, and if it has, it will pass it on to the next event. Let's have a look at the parameters for this test and see how this has been set up in our example, and also see what else we can actually do with it. So I'll just stop it playing there for a second before we go and have a look at the parameters. There's our find target test, as you can see here. As you can see, the first parameter that we have to deal with is this flyout here, where we can actually choose the control type. We've got a choice of control by speed, control by time, or actually no control whatsoever. So as you can see, we've got the default here, which is control by speed, and as I said, this is the default option, and it will actually use the speed of the particle as the main criteria to define the time frame within which the particle can actually reach its target. We'll quickly skip through the parameters in the control by speed group to see how it actually achieves this. As you can see here, we've got the control by speed group. And the first option is use cruise speed, and this option activates the next 2 parameters, which you can see here, for cruise control. Whilst active, you have explicit control over the particle speed, including some random variation if you want it. The alternative is to turn this option off and just use the accel limit to actually influence the motion of your particles. So you can see we have this first parameter here, which is active only when use cruise speed is turned on. And when cruise speed is active, this parameter defines the optimal speed that the particle should travel at to reach its target. So you can actually set it up here to travel to the target more quickly or more slowly. Then you can set up a random variation for this speed value, and as you can see in this case we've actually used 41. The next 2 parameters, as you can see, are accel limit and ease in. Accel limit actually allows you to define how quickly the particles can accelerate up to their full speed. With higher values, the particles will actually move in a more linear manner to their target. With lower values, they will be affected more gradually and produce a smoother arc. This value is relative to the speed value, which we covered here. So, if you use high speed values, you may wish to increase this value proportionately. The ease in percentage allows you to slow down the particles as they actually approach their target. Obviously, higher values will allow